Hello students, today topic is alkanes physical properties in the physical state C1 to C4, these are gases. In the C5 to C17 are liquids. C17 above are solids. Okay, but here C5, in the C5 neopentane is there. This neopentane is gas at room temperature. Okay, and isopentane has a low boiling point liquid. Then C6 onwards completely liquids. Then color is no color, that means colorless, we can say. Density is lesser density than water, less than water. Okay, that's why you can see kerosene, petrol, these all are, it will be float in the water. Okay, it will form one layer on the water, that means lesser density. Then solubility is not soluble in water, these are soluble in non-polar solvents like organic solvents, we can say benzene, carbon tetrachloride and cyclohexane, these are. Okay, here the topic is solubility, like dissolves like, that means polar compounds dissolve in polar solvents, non-polar compounds dissolve in non-polar solvents. Here hydrocarbons are non-polar, hydrocarbons are HC, hydrocarbons are non-polar, right. Next, boiling point generally directly proportional to the molecular weight, that means number of carbons are increasing, boiling point also increasing. That means CH4 say C2H6 has more than, like that, C3H8 dash. Okay, then boiling point is directly proportional to surface area. Suppose surface area, suppose if I am taking pentane 1 to 1, 2, 3, 4, 5. This is the N-pentane. Okay, N-pentane is higher boiling point than isopentane. 1, 2, 3, 4, total 5. Isopentane is higher boiling point than neopentane. This is the boiling point order. See, number of carbons are same, even though this neopentane, this is the neopentane has less boiling point. Why? Because it is a spherical shape, the surface area is less. So boiling point is directly proportional to surface area. Then melting point also is directly proportional to number of carbons. But here one thing we have to remember, 1, 2, 3, 4, 5 carbons, 3, 4, 5, 6 carbons. So in case of odd number, the methyl groups are same side, so some repulsion is there. But in case of even number, the terminal methyl groups are opposite direction, so no repulsion. So this melting point is higher than this melting point. Okay, of course is a 5 member, 6 member, it should be higher, but the thing is here, whenever it is changing from odd number to even number, this 5 carbon chain to 6 carbon chain, the melting point increase more. Whenever even number to odd number, is a 6-membered ring, then it will come 7-membered ring. Sorry, 7-member chain. So 6 to 7 carbon chain, increasing less. Okay, here odd number to even number increasing more, even to odd number increasing less. Sometimes you can see even, almost equal, little bit less also. Okay, then you can refer the textbook. In the textbook, one table is there. Okay, you can follow, you can refer that. This melting points is mentioned in the textbook. One table is given, you can refer that table. Next, chemical properties. Yes, chemical properties. The chemical properties, first property is oxidation. Complete oxidation or combustion. Combustion means what? Combustion means is nothing but the burning of the hydrocarbons in the presence of oxygen. Okay, so what are the products here? The products is generally carbon dioxide and water. Here complete combustion is there and incomplete combustion. Okay, that means insufficient oxygen. Whenever excess of oxygen is there, it is forming carbon dioxide, and then less amount of oxygen is there, insufficient oxygen is there, that is forming carbon monoxide and carbon is forming. Okay, now first thing, if excess of oxygen is there, whatever number of carbons are there, those many carbon dioxide molecules are forming. Whatever hydrogens are there, those many half of water molecules are forming. Suppose I am writing here C6H12, whatever. Then in the presence of oxygen, by burning, it is giving 6CO2 plus 6H2O. Whatever number of carbons are there, those many carbon dioxide molecule. Whatever hydrogens are there, in that half of water molecules are forming, because each water molecule required 2 hydrogens. Next, incomplete combustion. In incomplete combustion, we are getting carbon monoxide and carbon. Then catalytic oxidation. Yeah, this carbon is also known as carbon black. It is used in the printing. Next, catalytic oxidation. The catalytic oxidation depends on this catalyst. This is giving different compounds. Okay, that's why catalyst is more important. Here reactants are same, methane and oxygen, but here red hot copper iron tubes are there, methyl alcohol is there. Same red hot copper iron tubes, it will come in the alkyne chapter. It will produce benzene from acetylene. Okay, so these catalysts have a different functions with different reactants. Okay, so red hot copper and iron tubes, methane converted into methyl alcohol. Then molybdenum oxide is converting into formaldehyde. Next, these reagents you have to remember. Then alkanes on oxidation in the presence of manganese acetate give fatty acids. It gives fatty acids. What's happening here? Just the one of the terminal methyl group converting into carboxylic acid. The remaining chain as it is. Okay, manganese acetate. Then tertiary alkanes are oxidized to give tertiary alcohol by KMnO4. Tertiary alcohol. See here, just this hydrogen gets oxidized. Okay, so KMnO4, you have to remember these catalysts. Next, one sample question. Yes, one numerical we can see here. how many liters of oxygen required for complete combustion of 6 gram ethane? Here you have to write balancing equation first of all. After writing balancing equation, we will know that 2 moles of ethane react with 7 moles of oxygen, forming 4 moles of carbon dioxide and 6 moles of water. So according to this, first you calculate C2H6 molecular mass. C2H6 molecular mass, that is 24 plus 6, that means 30. So 2 moles means 60 gram ethane react with 7 into 22.4 liters of oxygen. So now the question is 6 gram how much? 6 gram how much? We don't know, that is x. So just you do the cross multiplication. Okay, then x equal to क्या होता है? X equal to नीचे 60 ऊपर 6 into 7 into 22.4, 6 1 ja 6 10 ja, then 10 means I can write here 2.2, 10 cut करके 7 into 2.2, 7 into 2.2 means 14 plus 1 extra, so approximately 15.6. Okay, just calculation you can do. Next, substitution reactions. The substitution reaction in alkanes show free radical mechanism. They give following substitution reaction. Halogenation. Generally alkanes are known as paraffins. These are not react with acid and base. Okay, only in the presence of light those are undergoing free radical mechanism. Then substitution reaction takes place, especially with the halogens. These are taking place substitution reactions. Now replacement of hydrogen atom by halogen atom. So simply RH becomes RH. Now halogenation is made on exposure to mixture of UV light to elevated temperature. The reactivity order for halogen shows the order. Fluorine is highly reactive, then chlorine, then bromine, then iodine. So the reactivity is decreasing down the group. As well, a reactivity order of hydrogen atom in alkane is the tertiary alkyl. The tertiary hydrogen has highly reactive than the secondary than the primary. Okay. Now fluorination. Fluorination reacts explosively in dark. Even light जरूरत नहीं है और dark में भी reaction चलता है. Fluorination can be achieved without violence when alkane is treated with fluorine diluted with an inert gas like nitrogen by the action of mercuric fluoride on bromo or iodo derivatives. So generally क्या होता है, alkyl fluoride if you want you can react with fluorine, but that is explosive. So without explosive, how can you make? You can make like this. You can take alkyl iodide you can take, then you take heavy metal fluorides, then this fluorine is substituting, so easily you can get RF. Okay, so again this type of reaction is there in the class 12th. Now chlorination. In the chlorination, it is a continuous reaction. First chlorine is replaces one hydrogen, then second hydrogen, then third hydrogen, then fourth hydrogen. So mixture of compounds we are getting here: chloromethane, dichloromethane, trichloromethane, tetrachloromethane, that is also known as carbon tetrachloride. Okay, here mixture of compounds. Suppose if you want only monochloromethane, that means chloromethane if you want, then you have to do one thing, excess of methane you have to take, less amount of chlorine you have to take. In that case you will get maximum chloromethane. Of course remaining compounds also will be there, but less amount. Now how this mixture of compounds are forming mechanism. Here free radical mechanism, these are undergoing free radical mechanism. First the chlorine is undergoing homolytic cleavage, forming chlorine radicals in the presence of light. These free radicals are highly reactive, highly unstable. So this chlorine radical immediately reacting with methane. So chlorine required only one electron, that's why again this chlorine radical react with methane. Again it is undergoing homolytic cleavage. Here one electron, here one electron. This chlorine radical and H radical is forming HCl. So it is generating methyl radical is generating. Then methyl radical is attacking with chlorine, neutral chlorine. Methyl radical ko chahiye only single electron species. That's why it is taking again homolytic cleavage. So again chlorine radical is forming. So you can observe here, in every step one radical is consuming, one radical is generating. One radical is consuming, one radical is generating. So this step is known as chain propagation step. The first one is chain initiation. In the presence of light, the reaction started, initiation. Now in each step, one radical is consuming, one radical is continuing, producing. That means chain propagation. Propagation means is the continuing the process. The third step is there, chain termination step. Whenever two free radicals are combining, it is giving neutral molecule, that means chain termination. See here like this. Okay, so here you can observe one more thing here, ethane also forming instead of chloro, dichloro, trichloro, tetrachloro, again ethane also forming. Next, bromination. The bromination reacts with alkanes in similar manner but less vigorously. Means itna reactivity down हो रहा है, down the group reactivity is decreasing. So bromine is more selective, less reactive. Iodine reacts with alkanes reversibly. HI formed as the byproduct as a powerful reducing agent and is capable of reducing the methyl iodide to methane. Actually what happened here with iodine, of course like chlorine bromine, it is also giving alkyl iodide. So at the same time the byproduct is HI. So this HI again, we know that this alkyl iodide react with HI is a reversible reaction, again forming alkene. Okay, so it is a reversible reaction. So to avoid this problem, whatever HI is forming, HI को immediately हम बाहर लेके जाना है, मतलब कुछ convert करना है. For that, what we are doing, we are taking HiO3, oxidizing agent. So HiO3, whatever HI is formed, that HI is converted into I2, iodine, in the presence of HiO3. Then alkyl halide will be remain same as it is. Okay. So to avoid this reversible property, we are taking HiO3, oxidizing agent. Next, reactivity selectivity principle. Here, this is the primary, tertiary, primary, secondary and primary. Here we know that the reactivity of fluorine, chlorine, bromine, iodine is decreasing. So that means bromine and chlorine में बहुत different reactivity है. So chlorine reactivity is higher, so selectivity is less. So primary hydrogen, secondary hydrogen, tertiary hydrogen में The selectiveness is just 1 is to 3.8 is to 5. This is the chlorine reactivity with primary hydrogen, with secondary hydrogen, with tertiary hydrogen. थोड़ा tertiary hydrogen से ज़्यादा react होगा comparatively first primary. लेकिन bromine केस में it is more selective. Which one? Bromine. See, bromine primary, secondary, tertiary है तो maximum tertiary के hydrogen को replace करते. Maximum the bromine is replacing tertiary hydrogen. It won't be react with primary hydrogen. Okay, this is the thing. So in case of chlorine, almost same, 1 is to, you can take approximately 4, 3.8 को 5. Then bromine में 182 and 1600. So based on this we can calculate the percentage of the compounds. See, now the question, what is the percentage of product obtained from monobromination of isobutane? So this is the isobutane, primary, it is the tertiary, primary and primary. So the bromine attacking at tertiary is a 1600 times preferred, it is only 1 time. So now how many hydrogens are there? Primary hydrogens, total primary hydrogens are 9 are there. Tertiary hydrogens are 1 is there, that means 1600, this is the 9. Then percentage, if you want to know the percentage of primary, 9 upon 1600 plus 9 into 100. Generally percentage, what is your percentage means? Your scoring marks by total marks into 100. Yes, scored upon total marks into 100, like that. Primary, how many chances are there? 9 positions are there, 9 hydrogens. So 9 upon total 1600 plus 9, 1609. 9 by 1609 into 100. This is the percentage. The tertiary product formation is 1600 upon 1609 into 100, that is 99.4 percentage. Okay. So like this you can do. So maximum, this is the this is the major product, this is the major product, this is the minor product. Like that for chlorine also you can do the calculations. Then nitration, vapor phase nitration. This involves the substitution of hydrogen atom of alkane with NO2 group. In generally it's not react, but at higher temperature it vapor state बोल रहा है, इसलिए some reaction is there. Here water is removing and RNO2 is forming. Okay, next. Here also nitro secondary hydrogen is little bit more reactive, that's why 2 nitropropane is maximum, then 1 nitropropane. Similarly sulfonation, in the sulfonation case also H2O removing. Okay, the tertiary hydrogen is highly reactive, you can see tertiary hydrogen highly reactive, then secondary, then primary. In case of halogenation, nitration and sulfonation, in all these 3 cases tertiary is highly reactive, then secondary, then primary. Okay, then chlorosulfonation, the reaction with a mixture of sulfur dioxide and chlorine at ordinary temperature in the presence of UV light is called chlorosulfonation. Chlorine is there, sulfonation, SO2 is there. So in that case sulfonyl chloride is forming, Okay, 1 hydrogen is replaced, sulfonyl chloride, actually SO2Cl2 is forming. This SO2Cl2, the structure is like this. Okay, here alkane is there, RH, this HCl is removing. Okay, then RSO2Cl, this is the mechanism. Okay, next, further hydrolysis of alkane sulfonyl chloride gives alkane sulfonic acid. Alkane sulfonic acid, that means the chlorine is replaced with OH. The chlorine is replaced with OH, then sulfonic acid is forming. Then it is react with NaCl, sodium salt of sulfonic acid, used as detergents. We learned in the class 10th soaps and detergents. Soaps are generally fatty acids of carboxylates. Here detergents are sulfonic acids. Okay, isomerization already we discussed, separate video. Okay, but